So this question has two blocks, masses m and large M, are being pushed along a horizontal frictionless surface by a horizontal applied force F as shown. The magnitude of the force of either of the blocks on the other is what? All right, let's read that last line again. It says that the magnitude of the force of either of the blocks on the other is what? So it's looking for block big M pushing on little m or block little m pushing on big M. So it's going to be one of the interaction forces right there. Well, I'm going to draw the big M. I'm going to draw its free body diagram. Its free body diagram says that I have a force pushing towards the right. I also know that I have some upward forces and some downward forces due to gravity, but I'm going to say I don't care about that because I just want the interaction, and the interaction is only in the horizontal direction. And I'm going to go ahead and set coordinate system right now, positive to the x direction. I also know that this big M box is going to feel the little m box pushing on it. So there's a normal force of little m on big M. Little m pushes backwards on big M. Similar, for little m, there's a free body diagram for this. And this is actually a pretty simple one. This just says that big M pushes on little m. There's a normal force because of this pushing together. Big M pushes on little m. This applied force is only on the big M, so it doesn't show up in this free body diagram. So now what I'm going to do is I'm going to just add up. That was a bad sigma. So bad sigma, but I get sigma F, my sum of my forces, is equal to my acceleration. In the x direction, I get F minus normal of m on m, little m on big M, is equal to my mass, big M, times my acceleration. And in the other case, I get, in the x direction, I get normal force big M on little m in the positive direction is going to be equal to little m times a. So it wants to know the magnitude of one force on the other force. Well, I probably don't want the acceleration. And I think I'm going to run into a problem very soon, because I can see that this normal force and that normal force, they're different subscripts. But I know that this is a Newton third law case. One object pushing on the other is the other same as the other object pushing on them. So this normal force, I'm going to redefine N, M, M, big M on little m, is going to be equal in magnitude to the normal force of little m on big M. And I'm just going to call this my normal force from here on out. Redefine a variable. Why? Because I'm sick of writing subscripts and I don't need them anymore. So just to be clear, this is F minus N is equal to big M A, and this guy over here is the normal is equal to little m times a. Well, this is big N divided by little m is equal to my acceleration, and I'm going to substitute this into the other side. See where that gets me. Well, when I substitute in these two guys together, I get F minus N is equal to big M times A, but A is big is N divided by little m. All right. Rearrange my equations a little bit. I'm going to get F is equal to N plus big M over little m times N. Just move this to the other side and rearrange some of my terms. So F is equal to N times 1 plus big M over little m. last but not least, F divided by 1 plus big M over little m is equal to our normal force. The normal force of one block on the other, which is what I defined as N. So now I just have to find the answer that looks like this. So I have F on top. Oh, this is not good. I'm going to multiply through by little m over little m. So I'm going to have little m here. It's going to cancel there. It's going to give me a little m there. So just rearranging it, just multiplying by a factor of 1, little m over m, little m over little m, and I can rearrange it. So I have little m times f, little m times f, not big F, and I get little m plus big M on the bottom. So little m plus big M on the bottom. I get choice A as my correct answer. So I just, again, solve the free body diagrams, use the free body diagrams to give me my Newton's second law equations, solve both Newton's second law equations, eliminated out one of my variables, didn't need to know A, and then just solve the algebra at the very end. So nothing horrible, nothing too complicated, just takes a little bit of work to get there.